And also we need to look into the future prospect and planning and acknowledgement. And remember that during the 13th five-year plan, and, actually the Central Party Committee issued a document to enhance storage and smart grid strategy. Back in the 13th five-year plan, actually we talk about that storage is a very important sector, and actually I was quite doubtful in the beginning, and actually we needed to look at the central news, but during the 14th five-year plan, I cannot scroll down, sorry. And in the 14th five-year plan, during the 14th five-year plan, actually it's very clear. And the ministries talk about the new energy, and therefore it is storage is a core of the state grid, and the PV, actually the power generation is just like a stone coal. So actually we have compared different battery for storage from 150. Actually, lithium is very good, and then for sodium battery, it is contrasted with LFP. And now the development state is very quick, and then over 2 hours or 4 hours, the main time is the VRFB. Therefore, we attracted some data. VRFB is quite similar to pumped storage. And also look at the large scale VRFB is a large scale application priority. And in the past 18 years, we focus on the VRFB and also the lithium solid state. We have done some sort out, and we calculated on the basis of carbon peaking and with the straight spike of PV and wind power. Actually, it has grown. It could grow by double, even triple. I have done calculation with a lot of PhDs, and the central document also mentions that by 2025, the renewable energy should reach 60% storage, and therefore should go at multiple fold after 5 or 10 years. It is a conservative data. And so you're very familiar about this principle. I guess you're quite familiar. So, and after I came back from Japan, I tried to follow the policies from abroad. Actually, in other countries, and we could see that many important manufacturers has done piloting, and a lot of places are following up. And in northwestern China, you can see that it has clearly talked about that over 4 hours of storage. It is dominated and designed for vanadium VRFB. And therefore, the policy has tilted towards the institutional reform, and it is regarded, and storage is one of the major technologies, and it is a very important device and system. And recently, different policies always come out. And in 2015, actually, we have done some prediction in 2015. The proportion of VRFT will reach 17.5%. And last year in 2021, and also we have a discussion in Changsha City, Hunan province. And also we found that it will have a very big proportion, which is that VRB's share is 20 to 30%. Therefore, in the future, we could see that vanadium VRFB will have at least a trillion size market. And also the National State Administration had a new document which is displayed. And actually, CACID battery is not covered here, but it is clearly stated later. then cassette is not allowed, and the lithium should not enter into storage market in Beijing. And we predicted that the LFP will be in one of the directions, and also LFP has been discussed entry into the large scale storage. Therefore, I looked into this document, and also in the document in 2018 May, actually these two documents are two major documents in 10 years to recognize. And also, the next one is the vanadium, since we talk about this very niche metal, but it should bear a heavy responsibility of what we should do. Actually, we have two types of resources. One is Pangang and Chengde, which is vanadium and titanium, and also the processing cost is very low. The second is another resource is which is stock coal. Stock coal capacity and the reserve are better than the ore, the vanadium ore, but it has a different technical path, and therefore the promotion is very slow. But in the long term, as reserve in China could help us to win this new energy battle. And based on the resource reserve and the prediction, we know that the future is very optimistic as the market is huge. And we have done some calculation. And actually we have 100 MW and 500 MW. And one system is just like 5,000 EVs. And if the storage market is very difficult to cut in, because the quantity is around 100 folds of power cells. And also our company is starting from 2007, and we have done a lot of research, and in 20 years, we have 200 people in our team. And our technical consultants amount to 20, and also PhDs amount to 20. And also we have 40% of our staff with at least a bachelor degree and a postgraduate degree. So you can see this profile. We have a lot of cooperation with universities and research bases. And previously, you can see those PhDs are working in our company previously. When I was studying, the energy density was 20, and upon my graduation, it became 70. And in 2015, and it was 100. And you could see the energy density kept improving. And also on the surface, we have some porous agent, and it is, you could see, this is the agent we use. And this is what we have done for 1 or 2 years. And we also have gained 1,000 cycles. And in order to gain the high efficiency battery, we have two connectivities, and on the surface, this is what we have done. And the agent we use is a potassium hexafluorophosphate. And we have done this for 5 years. And also, we have a new PhD on board. And so the best efficiency is 400, and it's a very good efficiency. So this is our calculation. In 2019, the price was 400 to 500 yuan. And also according to our storage needs and resources, we believe that the price of vanadium will just go down from 400,000 to 150, 120,000 yuan. And by the last year, the price has already dropped below 100,000 yuan. And therefore, we use it all for electrolyte. And starting from 2016, we handle some shareholders, and especially extraction from stock coal from 2004, from 2016, and actually stolen coal. The cost is quite appropriate for extraction. So this is the impurity control of the ions.
And in terms of the stack, we have also done much research. As you can see here, we consider different performance parameters, including open circuit voltage, maximum charging voltage, minimum charging discharging voltage, and maximum charging current and the maximum continuous discharge current, so on and so forth. We have developed our VT10000 stack, and if we consider a certain price per kilowatt hour, actually the cost is around 800 yuan per kilowatt hour. As for the control system, we have a team devoted to this. This team has done a good job. Currently, they have already achieved a break even, and they have started to make profits. And on this page, we could see our human-machine interaction interface that is intelligent. And so for 8 years, we have done so many things. On this page, you could see our integrated machine for VRFBs. And in Guangdong, we have done this demonstration project, and that is for carbon neutrality. This project is for carbon neutrality, and in 2020, we made clear about our dual carbon goals in China. Anyway, we hope that our technology and our equipment can make contributions to the realization of carbon peaking and carbon neutrality here in China. We hope that the cost can be optimized further. So 8 years back, the cost is about 8,000 yuan per kilowatt hour, and then we went down to around 3,000. I'm sure going forward, we can even go lower to 2,500 yuan per kilowatt hour. And actually, this market is really huge. I suppose that with a starting point and with a very good operating leverage, we can really transform the market. With VRFBs, we can create a huge market. That market could be worth more than 1 trillion yuan. So this is about myself. I graduated from Hunan Agricultural University. I worked with Central South University and Northeast University in Japan. And then I joined the Institute of Chemistry at the Chinese Academy of Sciences as a visiting scholar. And then I implemented some projects under the National Nature Science Foundation. Over all those years, we have received huge support from many experts and scholars. Look at this page. This page shows a list of experts that have extended support to us. We have learned a lot from them, and we really are grateful for that. In developing VRFBs, as I mentioned, VRFB energy storage could be a trillion yuan market. And I'm sure as technologies improve, we can really make a bigger difference. However, this is a long-term thing. We need to look further into the future instead of focusing on the short term. One of the matters would be the fluctuations in vanadium prices. My supervisor, Mr. Liu Yonghua, told me that if you want to industrialize a technology, you got to ensure that it can be deployed on a large scale in a centralized manner, and the equipment gotta be good enough. When the pieces of the puzzle are ready, we can achieve our goals, including our